Okay, I think it's working. Okay, pre-calculus, you have your quizzes returned to you. They're different quizzes because obviously they're not directly from your homework like all of the other quizzes have been this year, but this topic is so important that you must have these trigonometric ratios down. So next week when I return, you will have 3 opportunities to retake this quiz. It will not be the same problems, but it will be the same types of problems and the same number of problems. So please make sure you've got your chart down, as well as knowing which quadrants where things are positive and in which quadrants. So just keep practicing that chart and knowing where the angles are located. So let's go ahead and start in on the graphs of sine and cosine functions. So this is going to come from 6.4 and 6.5. And we're going to do graphs of sine and cosine functions. Hopefully you can see this okay. So let's remember what sine looks like. Let's do y equals sine theta or sine x. And we've got the y-axis. And then we have the theta or the x-axis. You can call it either one, but it's the input variable axis. And then there are 1, 2, 3, 4 quadrant angles. So we'll start at 0. We go around to pi over 2, then to pi, then to 3 pi over 2, then to 2 pi. So this is what we were doing with the candy on last Thursday. All right, and we've got a height of 1 and -1. So remember the maximum was at 1 and the minimum was at -1. Okay, and then for sine, we started at 0, 0, and then you included all the angles in between 0 and pi over 2, but at pi over 2 you hit a maximum at 1, and then you went into quadrant 3, and so sine is still positive in quadrant 3, and then you hit 0 again at pi. Then we come into quadrant, pardon me, this was quadrant 2. Then we're into quadrant 3 here. Sine is negative in quadrant 3. And so the angles get larger, but larger negative, and then you hit your minimum at 3 pi over 2. And then into quadrant 4 here, your values get smaller and they head up to actually get larger, but smaller negative, you know what I mean. And so the sine graph, the wave looks like this. Remember we did that with our candy and we discovered that, and then it continues on, right, in both directions. And then we have y equals cosine theta or cosine x. And so graph the same way. We have our y-axis and our theta or x-axis. So this is our input axis and our output axis. We have a height of 1 and a minimum of -1. We start at 0. We hit the different quadrant angles, so we go to pi over 2, pi, 3 pi over 2, and 2 pi. And then cosine at 0 is 1. So that's the maximum value of cosine at that 0 degree angle or 0 radian angle. When you go up to pi over 2 on your unit circle, well, the angles start to get smaller, and then at pi over 2, cosine is 0. In quadrant 2, so between pi over 2 and pi, cosine becomes negative and hits our minimum at pi. And then it goes back to 0 at 3 pi over 2, and then it hits the maximum again at 2 pi. So cosine looks like this. And remember, it continues on in both directions forever and ever. So those are our sine and cosine angles. Now look at, they look pretty similar. You could almost put one on top of the other. They're just shifted by, can you see how much they're shifted by? How much would you have to shift your, let's say your sine over to make it a cosine? You'd have to go to the left pi over 2 or 90 degrees. So it's a shift of pi over 2, shift of pi over 2 or 90 degrees. That's why they're called co-functions, is because they are 90 degrees or pi over 2 radians away from each other. So that's why secant goes with cosecant, because there is a shift of that 90 degrees. So I told you I'd tell you where the co came from. There you go. All right, so we've got the co-functions, and then let's talk about domain and range. So the domain for both of these, the domain for both the sine and the cosine, your input, we talked about this on Thursday before we left. So your domain, you can put in any value for theta or x. So your domain is all reals. Reals, there we go. And the range, we talked about this as well. Your range has a height of from 1 to -1 inclusive. So we can say -1 less than or equal to y less than or equal to 1, or you can write it in your set notation. You can say y such that -1 less than or equal to y less than or equal to 1, or you can write it in interval notation. So you go from -1 to 1. All right. These also have something in common in that they go on forever and ever, and they just keep doing the wave. So we talked about that behavior is called sinusoidal or periodic behavior. Sinusoidal or periodic behavior. And it goes on and on and on. So in this case, it takes a period of 2 pi for the function to, let's look at sine, to start at the origin, go up, come back and go down, and then hit the origin again. So it takes from 0 to 2 pi for all the values to be hit. Let's look at cosine. We start at the maximum at 0, we go down, we hit our minimum, we come back, and we hit our maximum again. It's also 0 to 2 pi. So the period of the function for both of these is 2 pi. In this case also, when we're looking at both of these, there is a height. The height is the same. We talked about that with the range as well, but the height is the same for both of these. If you go from the middle of the wave up, the middle of the wave and we go up, or the middle of the wave and go down, for either of these functions, it's 1 unit every time. So middle of the wave up or middle of the wave down, it's 1 unit each time. So that's a special name. It's called the amplitude. And in this case, for both of these, it's 1 unit. Don't worry, it will change later. But right now we're going to talk about our parent functions. So your parent function, you can add these actually to your other parent functions. Y equals sine theta and y equals cosine theta. Those are the parent functions. The general form of these functions, so when we can put in some shifts or reflections, we have y equals capital A sine, and then there's a fancy letter, Greek letter, omega, lowercase omega, theta. And then we have the same for cosine. Y equals capital A cosine omega theta. Each of these letters tells us a different piece of the puzzle. So the absolute value of capital A is the amplitude. So you know how high. My grandfather clock is ringing. It's 10:30 in the morning. So capital A, whatever that value is in the A location, is the amplitude. The period is equal to, well, usually it's 2 pi unless there's a value for omega other than 1. So 2 pi divided by omega would be an altered period. It would be either a longer period or a shorter period. But if it's just 1, then it will look like these parent functions. All right, one other thing we want to talk about are odd versus even functions. We talked about this in the beginning of the school year, so this is a good review for our final. Odd versus even functions. Odd functions. They are symmetric over the, okay, do you remember? It's been a while. Symmetric over the origin. Look, odd O, origin O. Even functions. They are symmetric over the y-axis. So if you plug in, let's say, a negative angle into sine. Sine, notice, is symmetric over the origin. If we continued the sine graph on, it's symmetric over the origin there. So sine, if we plug in sine of a negative theta, because of the symmetry over the origin or the nature of it, it's going to be a negative sine theta. They are the same thing. We talked about that at the beginning of the year. And then even functions are symmetric over the y. So if we look at the cosine function, see if you folded it along the y-axis, you would have symmetry there. If you plug in cosine theta, negative theta, pardon me, plug in a negative theta. You can't really see that, I'm sorry. If you plug in a negative, it does nothing because it's still, notice it's still above the x-axis, so you'll get out cosine theta. So cosine of negative theta is equal to cosine of theta. And then tangent also follows this behavior of sine. So the tangent of negative theta is equal to negative the tangent of theta. And then it works for their little cousins too. So sine and cosecant, tangent and cotangent, cosine and secant. All right. I know it's a lot of introductory vocab and building, but we've already gone over the functions before break. So this is kind of making it formal. So let's go ahead and do some stuff with this. Let's do an example. Determine the amplitude and period of, let's use the function y equals 5 sine negative 4 theta. All right, so write that down. Y equals 5 sine negative 4 theta. And then let's pull some information off of this. Well, you've got that negative there, and it's a sine function, so let's go back and look at. Sine is an odd function, so we can take that negative sign and pull it out. The negative, so we get y equals negative 5 sine of 4 theta. Next, let's find what our A value is. So A equals negative 5, and omega equals 4. So there's your A, there's your omega. So let's go ahead and take this a step at a time. So number 1, your amplitude. Amplitude equals the absolute value of A, so in this case it's the absolute value of -5, which is 5. So that means our wave will be, instead of 1 high, it'll be 5 high. So it's a bigger amplitude. And then let's look at the period. Period equals, look at our back at our notes, the period equals 2 pi over omega. So 2 pi divided by omega, and in this case omega is 4. So we've got 2 pi divided by 4, which equals pi over 2. So that means you're going to have a full cycle. You're going to have a full cycle in only pi over 2. That's kind of crazy. So you look at your sine graph here. You're going to have a full cycle, an up and a down, just in this little area right here. We'll get to graphing it in a minute, but that's interesting. So there you go. We discovered something. Alrighty. Let's take a look at, let's have you do number no, let's not have you do a number. Let's continue. All right, let's actually graph one. Let's do an example where we actually graph. Let's graph y equals 3 sine 4 theta. So let's graph this equation, this function. We're going to do the same things we did with the first example. So number 1, we need to find our amplitude and period. Well, let's pull out A and omega. I notice there's no negative sign, so we don't have to worry about even and odd functions right now because there's no negative sign. So let's pull out the A in this case is 3 and the omega is 4. So step 1, let's find the amplitude. So the amplitude equals the absolute value of 3, which is just 3, and the period equals 2 pi over omega. So this is just like example 1. So we have a period of pi over 2. All right, that's step 1. Notice we had step 1 in the first one, no step 2 because we weren't graphing, but this one's going to have a step 2 because it's asking us to graph. So step 2, you need to find 4 points between 0 and pi over 2. So sine starts at 0. Remember our graph sine, it starts at 0 and then it ends at the period, where the period ends. So in this case it was 2 pi, but this graph, we're going to have an end, the period is pi over 2. So we need to find 4 points between 0 and pi over 2. All right, this is easier than it sounds. Here we go. Here's my y-axis. Here's my theta. Here is 0. And then I need 1, 2, 3, 4. My fourth will be pi over 2. And we're starting at 0. So here's 4 points, 1, 2, 3, 4. We have 4 points on this part of, the 0 doesn't count as one of the 4, but the pi over 2 does. This makes it easy to split. So we've got, what's half of pi over 2? Or what's half of a half? That would be pi over 4. Well, then we're going halfway between 0 and pi over 4 for this little mark here. So this is pi over 8. And now we've just got to figure out, well, what's the distance halfway between pi over 4 and pi over 2? Well, this is 1 pi over 8, 2 pi over 8, 3 pi over 8, and then 4 pi over 8, right? That makes pi over 2. So those are our 4 points. You always need to find your 4 points. Let's put in our amplitude so we know that it's going to have a maximum of 3 and a minimum of -3. That's what our amplitude tells us. And then we know what the sine looks like, right? We have the basic wave, starts at the origin, goes and hits its max, back to the 0, hits the min, back to 0. So let's follow that pattern. We start at 0, we hit our max, back to 0, we hit our min, back to 0. Alrighty, so we know, and then it continues on in both directions. So that is our sine wave. Congratulations, you just graphed your first trigonometric function. Okay, so now I want you to try some. So I would like for you to try page 408. Yes, page 408. I would like for you to try number 45. Page 408, number 45. Give it a try. Why don't you pause the YouTube and give it a try. Okay, you're back. So let's take a look. Page 408, number 45, you had y equals -4 sine x. Let me move this out of the way, sorry. So your amplitude was negative, or your A rather, is -4, your omega is 1, so your amplitude is the absolute value of -4 is 4, the period is 2 pi over 1, so 2 pi. Then you need your 4 key points between 0 and 2 pi. Thankfully, we've done that before. That's the nice one, it looks just like the regular. So we go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Amplitude of up, maximum of 4, minimum of -4. You start at the origin, you go up to your max, 0, min, 0. Now I'm going to dot this because that's not actually the final graph, because notice there was a negative in the front. That guy right there. But you already know what to do with a negative. You've graphed many a function. This is a reflection over the x-axis. So your max becomes a min, zeros stay put, and your min becomes a max. So this purple wave is your answer. Okay, so let's move on. Let's look at shifting. So we're gonna shift things. Shifts will be shifty. Alrighty, so we've got to look at y equals, all right, we've got the standard form, so A, capital A, sine, and then we've got omega, theta, and then we're going to include now a vertical shift, so plus b, or we could say be really fancy and say beta. Same thing with cosine, so y equals A, or we could be fancy and say alpha, cosine of omega theta plus b. So your vertical shift is your b. I'm not sure why they switched over to b instead of k, but that's what your textbook will say b. It honestly doesn't matter what letter you choose as long as you know what's happening. Alrighty, so let's go ahead and graph one of these guys. Let's graph. Oh, there goes the clock again. Y equals -4 cosine pi x minus 2. Don't freak out. I know there's an x and not a theta. If you prefer theta, use theta. A variable is a variable. And let's look at all of our values. So the a value is -4. The omega value is pi. And the b value is -2. And from there, we can do our steps. So step 1, your amplitude is the absolute value of -4, so 4. Your period is 2 pi over omega is pi, so that will reduce to just 2. Interesting. And then your b is a vertical shift down. So your shift is down 2. All right, step 2. We need our 4 points. Starting at 0, I got 1, 2, 3, 4, and the 4th will be 2. Well, halfway between 0 and 2 is 1. Halfway between 0 and 1 is 1/2. And halfway between 1 and 2 is, you can do this, 1.5. 3 over 2, 1.5, whatever you like. But notice the pi's aren't there because they canceled out. Alrighty. This is a cosine graph. Oh, we have our max, sorry. Our max is at 4, and our min is at -4. We have a cosine graph, so that will start up at the top. I'm going to dot it because there's some other stuff that's going to happen. We go down to our min here, and then back up to 0, and then back up to our max. So there's a full cycle. However, we have the negative. So that means we've got to switch this guy. Reflected switch is not a mathematical term. I shouldn't use it. We have to reflect it in the x-axis. So this guy's going to go down here, and I'll go up and then down. I wish I had markers that are this lovely color for the whiteboard. All right, but then we also have a shift down 2. So everybody's going to go down 2. So this point here is going to go further down. 1, 2. The max is going to go 1, 2. The 0 is going to go 1, 2. This 0 will go 1, 2, and this will go 1, 2. So we go up. There we go. There's our function with a shift, a vertical shift, and a reflection. We are getting so good at this already. So now I want you to stop the video and work on page 408, number 59. Give it a shot, and I'll see you in a minute. Okay, hopefully you got it done. So 408, number 59. Y equals -6 sine of pi over 3x plus 4. Your a is -6, your omega is pi over 3, and your b is 4. Okay, then you've got your amplitude of 6. Your period is 2 pi divided by pi over 3, which, remember, multiplied by the reciprocal, you get 6 for your period, and you shift it up 4. Step 2. you got to do your 4 key points. So our 4 key points here, we've got 0 to 6. Halfway between the two is a 3. Halfway between 0 and 3 is 1.5. And halfway between 3 and 6 is 4.5. We notice it's a sine, so we do a standard sine. And then we do, oh, I didn't reflect it. That was so silly. Then we've got to reflect, so let's do that, a reflection of this. So that goes down here. I think Samuel is gaming right now, and so I hear his little responses to his friends. And there we go. So there is sine reflected, but then we have to shift it up 4. So let's do a different color. Disregard the purple one. That was a mistake. I didn't shift, or I didn't reflect. Okay, so up 4. So we go 1, 2, 3, 4. This one goes up 1, 2, 3, 4. This one goes up to 4. This one goes up to 4. This one goes up 4. So we have see right. Oh, this one has to go 4. 1, 2, 3, 4. There we go. And then we come back down to here. There we go. It's this blue one, not the purple one. I'm so sorry. I tried to be all slick and prepared for this lesson. There we go. So the blue should be your wave. Alrighty. Doing okay? A lot of little things to keep track of. Okay. So moving on, let's do, oh, this one's interesting. So this next example is going to give you a picture. Find it here. It's going to give you a picture, and then you are going to come up with the function. So here's the picture. You're going to find an equation for the graph shown. Don't feel like you have to rewrite this. There's plenty of practice in your book. So just take a look at it and then try and draw or write an equation for this. All right, so first thing you want to look at is, well, where does it go? What's the period of this? Actually, not even first. Let's look at what kind of graph this is. Is this a sine or a cosine? Does it start at the origin or does it start at its max? In this case, it starts at its max, so we know it's a cosine graph. It's a cosine graph. And the period, so here's a maximum here. The next time it hits the maximum is here. So how long did it take to get from one to the other? It took just 1 unit. So the period is 1. And then your amplitude, that's an easy one to figure out. So the halfway, so that'll be an amplitude of 3. Okay, so if the period's 1, we need an omega and we need an A. So let's take a look at this. Y equals, well, your A is 3, so 3 cosine omega theta or omega x, whatever you want. There's no shift up or down, so we have no B. So I'm not sure what that sound is, other than I think the neighbors are building something. Okay, so here we go. Let's figure out omega. Well, the period is 2 pi over omega. So in this case, it will be 2 pi divided by 1. So that means that, oh, pardon me, omega. Let me try that again. So that means 1 equals 2 pi over omega. There we go. Solving for omega, you multiply both sides by omega, so you can remove it from the denominator, and you have it up here. So omega equals 2 pi. So we can rewrite this as y equals 3 cosine omega is 2 pi theta. So there's your equation. Alrighty, go ahead and work on page 408, number 71. Go ahead and stop the video and work on that problem. Okay, so you're back. You did page 408, number 71. It's a cosine graph. The period was 8. The amplitude was 5. So finding your omega, 8 equals 2 pi over omega. So omega is equal to pi over 4. So your equation is y equals 5 cosine pi over 4x, or pi over 4 theta. Okay, go ahead and stop the video and take a little stretch break. We're going to move on to cosecant and secant after this. Okay, so here we are. We are at y equals cosecant of theta. But remember, cosecant's little buddy is sine. So we're going to think about the sine graph right at the moment. All right, so let's graph that really quick. We're getting very good at graphing these things. So we've got 1, 2, 3, 4 points. For just a sine graph, we go 0 to 2 pi, and then we can go pi over 2, pi, and 3 pi over 2. And we have a maximum of 1 and a minimum of -1. And sine starts at the origin and goes up, and then hits the middle, and then goes down, so on and so forth. All right. Dotting it though, because we're not actually talking about the sine function. We're actually talking about the cosecant function. And the cosecant is equal to 1 over sine theta, right? They're reciprocal functions. So we need to think in terms of reciprocals. What is the reciprocal of 0? Think about this. 0 divided by a number. What's the reciprocal of that? Well, it would be a number divided by 0. And what's a number divided by 0? It's undefined. And how do we graph undefineds? Undefineds get graphed with an asymptote. So anywhere you see a 0 on the sine function, it turns into an asymptote. Let's do that in a different color. Let's use our purple. So we've got asymptotes wherever the sine function is 0. Okay, let's continue thinking about reciprocals. The maximum is 1 here. What is the reciprocal of 1? It's 1, so the cosecant graph will be at 1. How about the reciprocal of -1? Is also -1. So the cosecant function and the sine function will have the same value at these 2 points. Let's think about these values here. These are values that are becoming increasingly larger as we go from left to right. So that means that the values, if you do the reciprocal, they will become smaller as you go left to right. So your asymptotic behavior, you're going to hug that asymptote and you're going to come down left to right towards 1. And then look at this guy goes, the sine part of the sine gets smaller as you go from left to right. So that means the reciprocal will get larger from left to right. So you have this funny little cup shape in here. Okay, so let's take a look down here. This, as we move from left to right, this guy becomes increasingly, well, it's hard when you're talking about negatives, but he's going to flip over and he's going to do the same cup function, but just going the other direction. And then here, same thing here. If we go, there's like half of a cup there, or you can do half of a cup down here. So that's what the cosecant graph looks like. And so let's talk about the domain and range. So the domain of a cosecant graph, well, we have asymptotes, right? Let's look and see where the asymptotes are located. 0, pi, 2 pi, and it would go backwards, right, at -pi and -2 pi. So any integer value of pi is a no-go. So your domain is, we can use x or theta, it's your choice. I guess I'll use theta, such that theta cannot equal integer values of pi. Your range, oh, there goes the clock again. It's now 11. The range, well, we see there's in between, there's an empty space, right? We only have graph up here and down here. So your range is everything larger than or equal to 1 or less than or equal to -1. So y such that -1 less than or equal to y less than or equal to 1. Or you can use your interval notation, actually interval notation this way, negative infinity to -1 and 1 to infinity. Okay, so then let's quickly next to it do the secant. So y equals secant, and his buddy is y equals cosine theta. So let's just do a quick cosine graph. Kind of feel like I don't give enough airtime to cosine. Okay, here we go. 1, 2, 3, 4. The period for a regular parent function is 2 pi, so we've got pi over 2 pi and 3 pi over 2, and the max for this is 1 and the min is -1. And cosine starts at the maximum and comes down to the minimum. All right, but the same thing happens with secant and cosine. Remember, secant is equal to 1 over cosine. So when we're doing a reciprocal, the reciprocal of 0 is undefined. So we can turn this into asymptotes here and here. And then we can do even one over here if you want. All right, so then our max, so the reciprocal of 1 is 1, so we know it's gonna hit there, we know it's gonna hit there, we know it's gonna hit there. And so we can do our little reciprocal function. Remember, they're just off. Secant and cosecant are co-functions, so they're off by 90 degrees. So they should look exactly the same, except for that shift horizontally. All right, but because of that shift horizontally, that does change your domain. So your domain for secant, your values are pi such that, theta such that, look at where your asymptotes are located. So they're located at odd values of pi over 2. So we can say theta cannot equal odd values of pi over 2. But the range for secant and cosecant are the same. So y such that y is between -1 and 1. Oh goodness, I totally messed that up on this one, didn't I? That is totally wrong. Y such that y is less than or equal to -1 and y is greater than or equal to 1. Boy, I biffed that. Same thing here. Y such that y is less than or equal to -1. Actually, it's not an and, it's an or. Or y is greater than or equal to 1. Interval notation, you go from -infinity to -1, 1 to infinity. Sorry about that mess up, you guys. I hope that it makes sense now, because I gave you the range of the sine and cosine function, not the reciprocal. Okay. Oh, and shoot, these gotta have a little boy, Cardi. There we go. Boy, howdy. All right, so you're doing okay with these? They're pretty straightforward. Should we do an example? Probably should. An example. Let's graph y equals 2 cosecant x minus 1. All right, let's see what we've got. We have a equals 2, omega equals 1, b equals -1. So for step 1, your amplitude is just the absolute value of 2 or 2. Your period equals 2 pi over omega, which is 1, so just 2 pi, that's nice. And then you have a shift down 1. Okay, let's graph this guy. All right, we're gonna pretend. We're gonna do a little kindergarten pretend for a second, and we're gonna pretend that our graph is y equals 2 sine x minus 1. So we're just gonna pretend that for a minute, because then we can do the reciprocal of everything at the end. All right, here we go. 1, 2, 3, 4. We go 0 to 2 pi, because that's our period, is 2 pi. Nice. All right, pi over 2, pi, 3 pi over 2. Is this part boring yet? I find it's boring. And an amplitude of 2, 1, 2, 1, 2. Okay, and it is a sine function, so we start at the origin, go down, go back up. Alrighty. Now, when you're doing these, do not shift until you've done your asymptotes. So do your asymptotes first. Asymptotes before shift. It will make your life a lot easier. So asymptotes go here, here, and here. Okay, and then we can shift it by, what are we shifting? Down 1. So let's go ahead and shift down 1. So this max goes down here. This 0 goes down 1. This 0 goes down 1. The min goes down 1. The 0 goes down 1. Okay, so then you'd have another dotted, because we haven't done this cosecant yet. There we go. So that's our shift down 1. Asymptotes we've done. There's the shift down 1. So then let's go ahead and put in the cosecant. So we can now do our reciprocal. Flip them up. Flip them down here. Alrighty. All right, so now I'm going to have you work. So pause the video and you're going to work page 417, number 29. Page 417, number 29. Here we go. Okay, hopefully you're back. Here we go, page 417, number 29. So you have y equals 4 secant of 1/2 x. So your a is 4, your omega is 1/2, your b is 0. So your amplitude's 4, the period is 2 pi divided by 1/2, or 4 pi. So your 4 key points between 0 and 4 pi, so you've got pi, 2 pi, 3 pi. Your amplitude is 4, so up 4, down 4, and you're doing a secant, so we're going to pretend it's cosine. That means you start up at your maximum, Go down, hit your minimum, come back up to your maximum at the end. Throw in your asymptotes. So we've got asymptotes here. We have no shift. That's kind of nice. And so then you can draw your reciprocal in. I hope that went okay. All right, so that is a cosecant graph and a secant graph. So let's look at tangent. You guys are doing well. Stay with me. I know it's a long one and I'm not even there. You can't even tease me to my face. Okay, here we go. Let's look at tangent. So y equals tangent theta. And this is one that we did with our licorice or Twizzlers. And I'm going to do this one pretty quick. So tangent, we had pi over 4, pi over 2. And then we looked at this side, negative pi over 4, negative pi over 2. And at those pi over 2's, it was undefined. But at 0, it's 0. And tangent, and then at pi over 4 and negative pi over 4, that's your 1 and negative 1. So then we would graph like so. That was our tangent graph from Thursday. And so our cotangent graph, we have, well, where it was undefined, guess what? Now it's going to become 0, and where the tangent 0, it's going to become undefined. So we're going to have an undefined here at 0, and we will have a 0 at pi over 2. I'm going to continue this guy over, so we hit pi. That's a pi over 4, that's a 3 pi over 4, and so at pi again we will have the asymptote. And at a half, it's 0. Now remember, it's reciprocal, so if this guy grew, the tangent grew to 0 from left to right, this one will shrink to 0 from left to right, and we'll hit, oh, there's our 1, so it'll hit 1 there, and it'll hit negative 1 over here. And so we will decrease. So this one increases from left to right, cotangent decreases from left to right. So that is the tangent, the cotangent. And remember, the period for these is different. The cycle repeats itself every pi units. So your period for these two is pi. Let's look at your domain. Your domain for tangent. We've got asymptotes at odd multiples of pi over 2. So we have theta such that theta cannot equal odd multiples of pi over 2. And your range is nice. Your range is all reals. And then your domain for cotangent, instead of odd multiples of pi over 2, you have integer multiples of pi. So we have theta such that theta cannot be integer multiples of pi. And your range, same. Range is all reals. All right, let's graph. Let's graph one of these guys. So we'll do an example. We'll graph, let's see, y equals 2 tangent x minus 1. Okay, a equals 2. Same way, we're going to do the same thing with this. So a is 2, omega is 1, b is negative 1. Step 1, your amplitude, in this case, is 2. Your period is not 2 pi over omega, but pi over omega. So in this case, it will just be pi over 1 or pi. And then you have a shift down 1. Okay, so let's graph it. This is a tangent graph. It's going to look like this parent function. The period's pi, so we don't even have to change these guys, because think pi over 2 to pi over 2, negative pi over 2 to pi over 2, that's pi units. So you do a half and then a half. So this will go from negative pi over 2 to pi over 2, and then we have our little pi's over 4's in between. And we have an amplitude of 2. So let's place our asymptotes. And then at pi over 4, tangent is 1, but this says 2 times, so our amplitude's 2, so we're going to have a point there. And we'll have a point down here, and it rises from left to right, going through 0. That's it. I think these graphs are easier than the others, to be honest with you. But now we have to do our little shift down. So let's go ahead and, I should have dotted that, I'm sorry. That's all right, we'll do it in purple. Move a shift down 1, take your 0, shift it down 1, take this guy, shift it down 1. So our shifted graph will look like that. Alrighty. Okay. And then one last graph for you guys. We're going to do a different period. So we're going to graph y equals 3 tangent 2x. So this has an a of 3 and an omega of 2 and no b, no shift. So number 1, your amplitude is 3. Your period is pi over 2. So for step 2, for our graphing, we have an amplitude of 3, 1, 2, 3, 1, 2, 3. And the period is pi over 2. So that means from this point to this point has to equal pi over 2. So halfway would be pi over 4. So we're going to place half on this side of the y-axis and then negative pi over 4 over here for the other half. So from negative pi over 4 to pi over 4 is pi over 2. And then we can fill in these halves with pi over 8 and negative pi over 8. So we know where the asymptotes belong now. And at pi over 8, we'll be up here at 3. Negative pi over 8 will be down here at negative 3. And then we can go through 0, and we rise from left to right for tangent. That's it. Alrighty? Okay. You are going to go forth, and you will conquer your homework. And so in this case, your homework, actually, yeah. So your homework is page 417. And I would like for you to work on numbers, let's see, what have I got for you? 17 through 39 odd. There should be plenty of time to work these out, work with each other. Solutions are where they usually are. A couple reminders though. So let's just do a little quick reminder. Reminders for you guys. All right, reminder number 1, you have your quizzes next week. You will have 3 opportunities for your unit circle stuff. So values on the unit circle. If you got 100% on that quiz before break, guess what? You are off the hook. You don't have to worry about it. But if you didn't get 100%, even if you just missed one, you still have to take them because you have to have 100% on these. All right. Next, another reminder, you're going to have a quiz next Wednesday over 6.3 and 6.4. So what we did today, and then we will go ahead, when I come back on Monday, we'll review and go over any of this that you needed some in-person one-on-one. We'll go over that, and then you'll be quizzed on Wednesday. That'll be like a regular homework quiz. All right, and then the other thing I want you to remember is to locate your chapter tests for this semester. go find them. They might be accordion folded in the bottom of your backpack, but go find those so that you have them to start your review with for the final exam. Alrighty? I will see you next week. Have a good one. Be good children. And I hope you had a great break. Thanks. Bye.